Another example, find the center of mass of the lamina where the density at the point xy is proportional to the distance from the y-axis, and we calculated the mass of this one, example 1, at 64K, so I don't have to do the m, I just need to find the moment about the x-axis and the moment about the y-axis of this region, and fairly easily done. Moment about the x-axis, just take our density function, which is, since it's proportional to the distance in the y-axis, so that would be k times x. So we got a k times x in there, and the y is the distance from the x-axis. And so integrating the region, I think if we drew stripes across this, you can see the top of the stripe is y equals x squared, the bottom is y equals 0, and we start making those stripes as 0 and quit making them at x equals 4. And so this is a doable problem, integrating this, y squared over 2, and y going from 0 to x squared, so we wind up with k times x squared squared, which is x to the 4th times this other x here, makes it x to the 5th. So k times x to the 5th over 2 dx, integrating that between 0 and 4, we get k times x to the 6 over 12, that's 6 times this 2 that was already here, and so we get an enormous number, 4 to the 6th, which is like 2 to the 12th, if you will, over 12. Well, 2 to the 12th is 2 to the 10th times 2 squared, and the 2 squared and the 4 in this 12 cancel out and give us 1024 is 2 to the 10th k. You should know 1024 is 2 to the 10th because that's how big a kilobyte is. So our answer for the moment about the x-axis is 1024k over 3. Similarly, the moment about the y-axis, okay, that means we get an extra x in our integrand. And integrating with respect to y, that's just a constant, so and y goes from 0 to x squared, so that would just give us an extra x squared, so we integrate k x to the 4th dx between 0 and 4. So it's 4 to the 5th, 1024 over 5 times k. And then when we say what is our centroid is 1024. There's a k in every one of these, so they're going to cancel out. So that over 3 divided by 64, and the k's cancel, as I said. And if you wanted to simplify this, I think I could probably simplify that. There, 16/3. So that's our since that was a moment about the x-axis, then we would use this for our y value of the centroid, and we would put this over 64 to give us our moment about the y-axis, which would give us our x value of the centroid.